Let's talk about adding and subtracting fractions. So before we get any further, let's just quickly go over the parts of a fraction. Numerator is the top number of the fraction, meaning the number of parts of the whole. So for the fraction 3 over 7, 3 is the numerator. It's part of this whole. The denominator, the bottom number of the fraction, meaning the number of divisions of a whole into equal parts. So the fraction 3 over 7, where 7 is the denominator. So always think as fractions as part of a whole. So 3 over 7 literally means if I have 7 blue boxes here, I've filled 3 of them. So 3 of the 7, or 3 parts of the whole, which is the whole would be divided into those 7 parts. Fractions can be added easily if they have the same denominator, right? So they have the same amount, or they're of the same whole, right? So I have 2 over 5 plus 1 over 5. Well, my one box here is of 5, right? There's 5, 1, 2, 3, 4, 5. 2 of them are filled. And the other is I have 1 inside 1, 2, 3, 4, 5. So 1 of 5. So when I have 2 plus 1 and both are of 5, I end up getting 3 over 5. When you add or subtract fractions with different denominators, you must always find the lowest common denominator. So this is the key. If I have fractions here that have a different denominator, I need to make sure those denominators are the same, or so that both fractions are of the same whole, or of the same amount. So 3 over 4 plus 1 over 2, I know that 3 over 4 and 1 over 2 are not the same, so I need to change one fraction. I can actually change 1 over 2 to have the denominator of 4, and how I do that is I take the denominator and I multiply it by 2. Now what I do to the bottom, I have to do to the top. So then this now becomes 3 over 4 plus 2 over 4. So they're of the same denominator now. So my denominator is the same, and I just simply add these together. 3 plus 2 gives me 5 of 4, 5 fourths. Second example, we have 1 over 2 plus 1 over 3. Well, I can't just simply multiply 2 to get 3, or 3 divided by 2 to get 2. So I need to make these the same. So in order for them to find the same denominator, I need to find the lowest common denominator, or the lowest common multiple. So the lowest common multiple for these would be 6, and I've written that over here. Now how did I get 2 to become 6? Well, I multiplied it by 3. What I do to the bottom, I do to the top. Same idea for 3. How do I get it to become 6? I multiply it by 2. What I do to the bottom, I do to the top. So now I have 1 over 2 is 3 over 6. 1 over 3 is 2 over 6. Now that I have the denominator being the same, I simply add the numerators, and I get my final numerator, which would be 5 over 6. Right? So common denominator, what does it essentially mean? It means what I've been saying the whole time, of the same. So if I have basically 1/2 and 1/3, I can't really add these together, right? Doesn't really make sense. But it's easier to add the parts if they are divided into smaller parts. So I visually broke these down into 1, 2, 3, 4, 5, 6. 3, 4, 5, 6. Right? So this is 3 of 6. And this is 2 of 6, which is the equation we did up here. So we can visually see this. So of the 6 spots, we have 1, 2, 3, 4, 5 of them full. So common denominator means trying to divide a shape up into smaller parts so that you can add or subtract the number of parts more easily. And we're always going to express fractions in lowest terms. It's much quicker and easier to see and understand 1/2 than it is, say, 4 over 8, or even 18 over 16, even though they are equal. To express fractions in lowest terms, see if there are any obvious multiples on the top and the bottom. So the examples we have, if both numbers are even, like 8 and 14, then divide the top and bottom numbers by 2. Right? So 8 divided by 2, 14 divided by 2 gives us 4 over 7. We can't really go any further, so this would be lowest terms. If both numbers are multiples of 9, like here, 18 and 45, then divide the top and bottom by that 9, and we end up getting our lowest term, which would be 2 over 5. If both are multiples of 6, like 24 and 30, then divide the top and the bottom by 6, which would end up getting 4 over 5. Sometimes you may need to reduce the fractions several times if you can see it's not in lowest terms, right? So we have a big fraction here, 84 over 96. Well, if I can kind of chop that in half, I can chop both of these in half, right? Because 84 and 96 can be divisible by 2. I end up getting 42 over 48. Okay, I can keep going because they're even numbers. I get 21 over 24. Okay, I can't do 21, but I can understand that, oh, hey, these get divided by, and I can reduce them to 7 over 8. I can divide both 21 and 24 by 3. So 21 divided by 3 is 7. 24 divided by 3 is 8. A mixed number is a number that is part of a whole and a part fraction, such as 5 and 4/7. An improper fraction is when the numerator is greater than the denominator, such as 15 over 7. Quickly, how to change mixed numbers into improper fractions. So we have 2 and 3/4. So in order to do that, I take my denominator and I multiply it by my whole number. So 4 times 2, and then once I have that value, I then add the numerator. So I just wrote here 4 times 2 plus 3, which would end up giving me 11 over 4. So my visual representation simply means all of the items that I have are broken down into quarters or fourths. I have 2 full pizzas of quarters. So here's 1, here's 2, broken down into 4, and they are full, right? So there's my 2 whole ones, and then I have remaining of the 4 here, 1, 2, 3. So I have 3/4 of this last one. So I have 2 full and then 3/4. But if I look at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, so how many quarters of pizzas do I have? I actually have 11 quarters, which is what that improper fraction means. Second example, we have 3 and 1/5. We don't need to do a picture every single time. Go 5 times 3 plus 1 gives me the value of the improper fraction, which in this case would be 16 over 5. So quick note, in high school math, we prefer not using mixed fractions. Make everything improper. We want improper fractions. This is what we want, okay? So when we compare fractions in terms of which one is larger, I have 3 over 5 or 5 over 7. So if I compare the picture, well, this is broken into 1, 2, 3, 4, 5 spaces, and this is what 3 of them look like. Well, the other one is broken into 7 spaces, and I occupy 5 of them. Visually, we can tell that this one contains more, or which this one is larger. The second method would be to make a common denominator. So again, 3 over 5 and 5 over 7. How do I get these denominators to be the same? Well, if I turn into 35, 5 times 7, what I do to the bottom, I have to do to the top. So 5 times 7, 3 times 7 gives me 21 over 35. For my fraction of 5 over 7, multiply it by 5, I get 35 as my denominator, and I multiply the top by 5, and I get 25 as my denominator. So now that I can compare these, because they have the same denominator, it's also easy to determine which fraction is larger. There are more here because the numerator is larger. 25 is larger than 21. Circle the greater fraction and explain why. So I have 4/5 or 6/10. Well, in one shot, I can't really just determine that. I need to make them as common denominators. So 4/5, I can turn 5 into 10 by multiplying it by 2. What I do to the bottom, I have to do to the top. So 4/5 is the same as 8/10, or 8 over 10, which is more than 6 over 10. So that means that 4/5 is greater than 6 over 10. 2 more examples here. Quickly show why 3 over 8 is not equivalent, is not the same as 4 over 9. Okay, so again, find the common denominator. A quick trick is if we take both denominators, if I take 8 and I multiply by the other denominator, which in this case is 9, you will always get that common denominator. It may not be in lowest terms, but it will be common. So I take 8, multiply it by 9. What I do to the bottom, I do to the top. I end up getting 27 over 72. I take 9, multiply it by 8. What I do to the bottom, I do to the top. To make it equivalent, I get 32 over 72. So when I look at both of these, well, 32 is not the same as 27, so that is why 3 over 8 is not the same as, or not equivalent to, 4 over 9. Right, so quickly explain why it does not work to add numerators and denominators to add fractions. So why we can't just simply add everything we see together. because we are not using the same whole, right? And this illustration up here does a pretty good job of breaking that down, right? So I have, these aren't the same. I need to make them of the same in order to add them properly, right? So the big takeaway, making sure that everything has a common denominator before we add or subtract fractions.